You're solving a Sudoku puzzle. You place one digit, and suddenly dozens of cells become impossible. Cascading eliminations solve the puzzle. But here's the puzzle. Why does adding one constraint eliminate millions of possibilities, when search algorithms need to check millions to find one solution? Let's think about how you solve problems with lots of constraints. You're scheduling a conference. 50 talks, 10 time slots, multiple rooms. Constraints. 2 talks can't overlap. Speaker can't give 2 talks. Audiences shouldn't conflict. If you tried every combination, 10 to the 50th possibilities. Intractable. But watch what you do naturally. Assign talk A to 9 a.m. This eliminates 9 a.m. from talks B and C. They conflict. Now talk B has fewer options. Maybe B fits only in 10 a.m. Place it. Now talk C has fewer options. You cascade. From 10 to the 50th to maybe 10 to the 10th. Why? Because constraints aren't obstacles, they're information. Each constraint eliminates impossibilities. When you use constraints as you go, the search space shrinks exponentially. This is the power of constraint satisfaction. Not exploring blindly, but eliminating systematically. Brute force is hopeless. Sudoku. 10 to the 77th possibilities. Your computer would take longer than the age of the universe to solve it blindly. Scheduling 50 talks. 10 to the 50th. Chess. 10 to the 13th. But here's what's weird. Humans solve Sudoku in minutes. Why doesn't our brain explode? Because we don't explore blindly. We use constraints to guide exploration. Sudoku. If I put 5 here, then 5 can't go anywhere else in this row. We eliminate before exploring. Humans are constraint propagation engines. We recognize patterns, eliminate impossibilities, and focus on remaining possibilities. This is actually deep mathematics. Here is how constraint satisfaction works. 3 pieces: variables, domains, and constraints. Variables. What are you assigning? Domains. What are the options? Constraints. What rules must be satisfied? Piece 2. Constraint propagation. When you assign talk A to 9 a.m., propagate, remove 9 a.m. from all conflicting talks. Propagation cascades. One assignment triggers dozens of eliminations. This is how search space is pruned. Piece 3. Backtracking when stuck. If you hit a dead end or a contradiction, you backtrack and try another value. But it has limits. Hard instances, like the traveling salesman problem. Constraint propagation doesn't help much there. Remember the original question. Why does one constraint eliminate millions of possibilities? Because constraints are information. You assign one variable, update domains, and cascade. This process alone solves many complex problems effortlessly. The problem isn't search, it's representation. Represent your problem as a CSP, and propagation becomes a weapon. Next time you face a complex problem, think, what constraints can I recognize? Constraints do the searching for you.